Hello everyone. Today I will talking about derivatives. Firstly, I can introduce the definition of derivative. The derivative means a function of a real variable measures the sensitivity to change of the function value with respect to a change in its argument. Now, we can use a coordinate axis to show the meaning of derivative. We can draw in a chart of a function, it is fx. On the point A, we can draw in a line, which is a tangent line on the point A. The x-coordinate is x. On the point B, drawing another tangent line, the x-coordinate is x plus h. The distance between A and B is h. And then the function of slope equal to rise out of Wang equal to delta y out of delta x. So, the slope equal to y1 minus y0 out of x1 minus x0. The coordinates of all second line are x plus h, fx plus h, and x fx. According to the slope function y1 minus y0 out of x1 minus x0, we can find that derivative fx equal to fx plus h minus fx out of x plus h minus x. Therefore, derivative fx equal to fx plus h minus fx out of h. Why the derivative fx equal to fx plus h minus fx out of h? Because the distance between point A and point B, h is small and small. We can think that h tend 0.
Now, let's look at the application of derivative in real life. In economics, derivative equal to marginal. People can use derivative to calculate marginal cost, marginal revenue, and profit maximization. Marginal cost is equal to changing cost from one additional unit of production, which is equal to changing cost over changing quantity. So marginal cost is the derivative of cost with respect to quantity. Marginal revenue is changing revenue from one additional unit of production, equal to changing revenue over changing quantity. Marginal revenue is the derivative of revenue with respect to quantity. In real life, business can use derivative to calculate and maximize the profit equation because revenue and cost are both expressed as a function of quantity. Business determines the profit maximizing quantity of output by taking the derivative of the total profit equation with respect to quantity, and set the derivative equal to 0. Also, profit maximized when marginal cost equal to marginal revenue. We can see the graph of profit function show the profit maximized when the derivative equal to 0. First, profit is equal to revenue minus cost, or RQ minus CQ. Business can use derivative to calculate the profit maximized points when the derivative of profit equation equal to 0. Then, we can write derivative of revenue minus cost with respect to quantity. When the derivative equal to 0, the equation of derivative of revenue with respect to quantity equal to derivative of cost with respect to quantity, which is marginal revenue equal to marginal cost. When the marginal cost equal to marginal revenue, the profit is reached the maximizing point.
Let's look at an example. Suppose we have a product with a demand equation given by quantity equal to 10,000 minus 200p. P is the price, and the cost equation is 12,000 plus 20q plus 0.0025q squared. We can use the demand equation to divide revenue a function of q. First, we can add 200p to both sides of the demand equation. Second, subtract q from both sides of equation, and divided both sides of equation by 200. We can write p equal to 50 minus 0.005q. To determine revenue, multiple price and quantity equal to 50q minus 0.005q squared. So profit equal to revenue minus cost, which is minus 12,000 plus 30q minus 0.0075q. After we have total profit equation, we can determine the profit maximizing quantity and price. The derivative of total profit equation with respect to quantity equal to 30 minus 0.015 Q. Next, we set the derivative equal to 0 and solve for quantity, which is 2000 units. Substitute the profit maximizing quantity of 2000 into demand equation and solve P. Price is $40. Finally, maximized profit is determined by substituting 2000 for quantity in profit function. So when the price is $40 and the quantity is 2000 units, the profit will maximizing at 80,000.
Application of derivative. Example: we throw a ball into the air at speed v equal 4 meters second. We can predict how high the ball is at any time using the equation ht equal vt minus 9t squared. At what time does the ball reach its maximum height? Solution: to calculate the maximum height, dh divided dt equals 0. So, dh divided dt equals 4 minus 9t equals 0. 9t equals 4. T equals 4 divided 9. So, the ball reaches its maximum height when t equals 4 divided 9. Example:
a firm's short-run production function is Q equals 6L squared minus 0.2L the power of 3, where L denotes the number of workers. How many employees must the firm hire to maximize output? Solution: to maximize output Q, dQ divided dL equals 0. dQ divided dL equals 12L minus 0.6L squared equals 0. 0.6L squared minus 12L equals 0. L squared minus 20L equals 0. L squared minus 20L plus 100 equals 100. L minus 10 squared equals 100. L minus 10 equals 10 or minus 10. So, the first L solution is 20. The second L solution is 0, but reject. So, the firm must hire 20 employees to maximize output.
Learn about the various ways in which we can use derivative to study functions and solve real-world problems in real life.